Hello students, welcome again in our chapter 6 AOD. AOD means application of derivative. I hope students you by heart our all formula for derivative and basic formula we written in the part 1. Yes students, today I continue our 6.1 exercise remaining questions after that 7th one. So let's start question number 8. A balloon which always remains spherical or inflation is being inflated by pumping means pumping in the air for 900 semi cube per second. Means every second 900 semi cube entering air in this balloon. So find the rate of radius of the balloon increase when the radius given 15 cm. It's very easy sum, but here look at that first of all. 900 semi cube per second. It means derivative respect to second. This time? Yes. Here your balloon is always in the form of spherical after entering air. So don't worry. It means the shape is not changing. Radius given that initially 15 cm and given volume. So dV versus dt 900 semi cube per second. And question is that if radius is initially 15 cm, then asking that how fast radius is changed means dr by dt is my target. Very easy. Yes. What is the formula? Volume of sphere? Yes, correct thinking you. Volume of sphere. Either spherical balloon. It is 4/3 pi r cube. Now, I take derivative respect to time. This is the main step which have to take derivative respect to time or respect to radius. It is decayed in your question. So, differentiation with respect to t. So, dv versus dt. Now, very easy solution. It is going to 4/3 pi and here d by dt of r cube. Easy derivative, d by dt given. Just only check it is unit is same. Sometimes not same, huh? So you must be checked unit is same or not. Now put down the values. So dv by dt here 4/3 pi and what is the derivative of r cube? Respective. So 3r square dr by dt. And after that you just put down there 3 cancel d by dt no and happily your numerical is done. So here value is 900 4 pi and radius I have 15 square. dr by dt is my target. It's very easy. So 900 divided by 4 pi 15 square. I write down 15 into 15. You don't write down 15 square direct 2 to 5. It's simple cancellations. Yes, here cancel 15 6 are 90, 0 as it is, and 15 4s are 60. Only you have dr by dt 1/pi centimeter per second. It means if you volume increase in the balloon every second 900 semi cube. So radius if you 15 semi, after that they expand every second 1/pi centimeter. Your radius is increased. Yes students, it's very easy. So now next I go after that. Now students, I go in next one, question number 9. And after that I explain you 10. But don't worry, I just only written question. 9th question is that a balloon which is always remains in spherical form. It means sphere form given. And variable of the radius, find the rate of which its volume is increasing with the radius. What is increasing? Read properly. It is radius is increase and asking that find out volume increasing for the radius level. If a radius is given 10 centimeter. Students, here derivative respect to radius, because radius is changed, then volume change. So here by one of the sphere, consider, and that is your radius. Radius is given 10 cm, means if radius is 10 cm, then volume increasing after increasing radius. So dV versus dr. This is my target. Yes, I again repeat you, in not given time, volume change after changing the radius. Means radius is increased. Definitely, volume of is also increased. So, what is the volume of sphere? Yes, very easy. 4 by 3 pi r cube. And derivative, differentiation with respect to its radius. This is the main point. So, dV versus dr. Here 4 by 3 pi. D of dr. Now derivative, it's very easy. 4 by 3 pi, 3r square, and here dr by dr itself 1. 3 cancel, and dv by dr. We happily derive our answer. Yes, students, here dv, by mistake I written small b, and 4 pi. What is the r? Remains is 10. It means 10 centimeter sphere given. After that the increase. Initially is 10, this is 10. So here 10 square and it is the 1. So your answer 100 into 4. 400 pi. In units, volume respect to radius. It means centimeter cube per centimeter. You not cutting down semi. Yeah? This indicate volume side and this semi indicate radius side. And this is happily, easily done. Yes, students. Now, after that time we ahead, question number 10. Now, students, going ahead, next question. Question number 10. This is the IMP question. So, you pick mark in IMP list. Question is that a ladder 5 meter long is leans against the wall. The bottom of the ladder is pulled along the ground and away from the wall at the rate given 2 centimeter per second. Per second means time given. Derivative respect to time, and how fast height is decreasing when the foot of the ladder is 4 meter away from the wall. Very easy. Consider this is your wall and here your baseline, and that's your ladder. This is my ladder. Properly made the drawing. Yeah? Yes. Here A to B. Consider it is a wall. X meter given. Here baseline 1 meter BC, and AC is my ladder Z meter, which is given 5 meter. Now, students, question is that this ladder is pulled down. It means here ladder is decreasing that level, and asking that how fast is height is decreasing. This your height is decreasing is this asking. Dx by dt is your target, and 2 centimeter per second is again rate away from the wall at the rate. It means this given dy by dt 2 centimeter per second. This semi given, this meter given. So you change in semi to meter, either meter in semi, both of the kind. And read that here away from the wall is given 4 meter. This distance is given. Now students, here just by asking you, and you also think about that, if this ladder is pulled down, then slightly away from the wall, then AC length ladder 5 meter, increasing or decreasing? Yes students, correct thing about increasing or decreasing? Yes, it is same. No increase, no decrease. Length of the ladder. It means it is constant. And constant derivative is 0. Again asking you. This AC length, if you slightly move away from the wall, ladder is same. Only height is decreasing. Bottom is decreasing. It means length of the ladder is same. It means constant. So its derivative is 0. That's the main point. So here I am taking AB equal to height of the wall, and which is given how much? X meter. It is a given? No, it is my target. Now after that, we see, I just assume that y meter, given that 4 meter, and length of the ladder, you see, it is the length of ladder. And how much it is a 5 meter. Now first of all, I find out this x. After that, I utilize my derivative. But here meter, length of the ladder 5 meter, it is a constant. Are you clear why constant? Ladder length is same after slightly moving away from the wall. Yes students, now I start one of the Pythagoras and find out height of the wall. And after that, we can easily clean our derivative. So, in a triangle, yes. In a triangle ABC, AC square is equal to AD square plus BC square. We have Z square, X square plus Y square. Here 5. X square unknown, but Y is known of 4. Yes, you easily getting X value. So it gets here modified. X square plus 16. X square is 9. X is a 3 meter. Don't take negative here because length of the ladder. This is a 3 meter. Now this meter, it is semi. So meter change in semi, either semi change in meter. Here I take meter 2 by 100 meter per second. And overall numerical I calculate in the meter. Now this is the main point. This again I am checking here. Z square is equal to X square plus Y square, and differentiation with respect to time, because here second given time versus ladder is slightly away from the wall and decreasing the height. So d by dt of z square, same d by dt x square, same d by dt y square. Now take the derivative. It is 0. That's the main point to written here. Constant. And here 2x dx by dt. 2y dy by dt. So minus 2x dx by dt. 2y dy by dt. That's the answer. And x value known. This no 3 meter. So minus 3 dx by dt target. Y 4 meter and dy by dt is a 2 by 100. Students, I calculate in meter because here also utilize your meter value. And now easy. This cancel 4 and 25. So what is the answer? Dx by dt, which is minus 2 by 25. And here 1 by 3. So your target is done. Minus 2 by 75 meter per second. This answer correct, no doubt. But sometimes answer given in centimeter also. So I convert in the centimeter. So minus 2 by 75. Here 100 centimeter per second. And this also easy. 25 4s are 25 3s are. So what is the height is decreasing? It is minus 8 by 3 centimeter per second. Students, minus is indicate only what only? It is decreasing height. That's why only. And that's after that we write down. Therefore height is decreasing at a rate of 8 by 3 centimeter per second. But in this whole numerical, its main point is that this is the main point. Height is constant taking because AC is the same in any situation. Either this situation, either slightly going down that height and that also same. Yes, students, these are IMP questions and this is easily done. Now I am doing 11th. Now students, we are going again same name, slowly, same pattern. Question number 11. And after that, I explain 12. Students, see in the 11th question, a particle move along the curve. Curve is given 6y is equal to x cube plus 2. Find the point on that curve. But condition is that y coordinate is changing 8 times as fast as the x coordinate. This meaning, students, you just highlight, and this meaning is what? Y coordinate is changing, but respect to, you take any respect to time, either respect to theta, I taking time. So dy versus dt is 8 times changing for x coordinate, dx versus dt, and that's the given part, and that's how you utilize in this question. And derivative for the curve with respect to t. So for the curve, I have to curve given 6y is equal to x cube plus 2, and only take derivative with respect to t. So differentiation with respect to t. So 6 dy by dt. Here d by dt of x cube. And here constant, derivative 0. So 6. What is dy by dt? 8 times dx by dt. And that's I put down there. And here 3x square. But x derivative. Respect to t. This cancel. Correct? Now easily done. So what is your answer? 6 into 8 by 3 is equal to x square. It is 3 2's means total x square is equal to 16, means x is equal to plus or minus 4, this plus or minus 4, one time take q plus 4 and second time take q minus 4, and 2 points is derived on that curve. So I just going to slowly, one time take x equal to 4, means if x is equal to 4, so what is your curve? 6y is equal to x cube plus 2. Here 4 cube plus 2. 4 cube 64 plus 2, it is 66. It means y become 66 by 6, 11. So this point is clearly known. It is 4, 11. Same way, x is equal to now minus 4 and y getting. So if x is equal to minus 4, so what is the 6y? X cube plus 2. Put down the x. My x value is a minus 4. Means minus 64 plus 2 means minus 62 and divided by y. So my answer is minus 62 by 6 minus 31 and 3 2's are 3 2's are and 31 2's are. So 2 to 1 31 by 3. So this point is also ready on the curve, which is what, x comma y minus 4 comma minus 31 by 3. So one point is that, second is this, and this both answer you clearly here known for the on the curve. Yes. So does this line I have again repeat to you? Y coordinate changing given is 8 times the fastest than x coordinate changing. So it means dy by dt 8 times dx by dt, and that value I utilize it in place of dy by dt. Yes, students. This is the 11th question done. Now students, I start one more numerical. 12 is also very easy. Radius of an air bubble means it is a sphere is increasing at the rate half centimeter per second. It means students, this is your sphere and consider that's your radius. But radius is changed, is increasing So dr by dt, you checking here half centimeter per second. Shouldn't sometime decreasing even then is minus 10? Huh? Yes. And volume. At what rate the volume of bubble increasing? When the radius is 1. Means if r equal to 1 semi, then asking volume change dv versus what? dv versus dr or dt? Yes, it is the time. So here dt is my target. So you properly read the question one time, two time, three times, students. Now I go to volume of sphere. It's very easy. What is the volume? 4 upon 3 pi r cube. Then apply the derivative. Differentiation with respect to time. So dv versus dt. Here 4 by 3 pi, and here derivative for d by dt of what? R cube, and apply the derivative. Easily done. So your answer is the dv by dt. It is your target. Here 4 by 3 pi, and what is the R cube derivative with respect to time? It is 3 r square, and dr by dt. Students, 3 gone. R known initially 1 semi, and also radius changing given half. So my answer is 4 pi r square. It is 1 square, and dr by dt what? Half. And you also check, students, your unit is same, semi. Yes, definitely same. You getting the answer here. So dv by dt, this cancel. Choose that. So 2 pi and unit centimeter cube per second. That is the volume increasing every second. If you radius change every second, half second, then volume is changed to pi centimeter cube per second. Yes, students, very easy numerical. Now after that, 30. Now students, I going ahead. One more questions. 13 and 14. Both of the most IMP questions. Students, it is the most IMP numerical, and this also most IMP numerical. Many times asking in our exam. Question is there. First of all, 13. A balloon which is always remains spherical, having diameter given 3 by 2 2x plus 1, and asking the rate of change is volume with respect to x. Yes, students, this is your balloon spherical forming and radius given. You know that volume formula? Yes, volume of sphere V 4 upon 3 pi r cube. Yes, that's I applying here, and r equal to radius. But radius you know generally it is diameter by 2. Diameter given. So that's the diameter I applying here. 3 by 2 2x plus 1 by 2. So your 3 by 4 2x plus 1. And now let's start. Volume V 4 upon 3 pi r cube. Students, you wait. You can't change derivative direct respect to x because you have no term in the x. That's why this r in the x terms I operate that, and my target dv versus dx. This is my target. Yes, students, you clearly about your target. Huh? So here I V, and these are that one 3 by 4 2x plus 1 the cube. I just apply and check your equation is in form of x. Now derivative easily done. So first of all we simplify. First of all 4 by 3 here 27, 4 cube 64, and 2x plus 1 the cube. See this. This cancel, 9s are cancel, 16s are. So we become 9 pi by 16, 2x plus 1 the cube. And here students, we start derivative with respect to x. That's the main point. That's why this question is an IMP. Now students, start differentiation with respect to x. You not taking derivative here x. That's why I converted in the x and going in the like term x and the derivative. So dv versus dx 9 pi by 16 and d by dx of 2x plus 1 the cube, and now easily done your sum. So dv by dx 9 pi by 16 and here take derivative respect to x 3 times 2x plus 1 square into what? 2x1 and 1 0. This derivative 2x1 and 1 0. This 2 and this 2 cancel. 8 2s. And final answer dv by dx is done. 9 3s are 27 by 8. And here 2x plus 1 is square. Here no unit given, but numerical is done. That's the easy way and simple solutions. 27 by 8 and 2x plus 1 square. That is the volume changing with respect to x. I hope students you understood that type of numericals. Now one more IMP sum, most IMP, question number 40. So question is there, sand is pouring from a pipe at the rate of 12 centimeter cube per second. Students, here volume given, and second is that time, derivative is respect to time, and falling sand form a cone. Means your drawing is, consider this is the one of the pipe and these are the falling sand pipe wise on the ground and making a cone. Definitely by naturally it is made cone, and cone have height, radius and L, and that is our fundamental. And volume given dV versus dt, you have to given 12 centimeter cube per second. Now for the rate, the falling sand from a cone on the ground in such a way that height of the cone is always 1/6 of the radius. Means this after falling the cone, the sand height is always 1/6 the radius. This given for this cone. Means the way of pipe, all the sand is dropping down there and the height is increased, but in which form? Cone. And checking the question, how fast height is changed and increase if the height is initial 4, is this initial given 4 cm. It means if height h 4 cm, then asking that height changes time wise, this is your target. It means the load required for R. So what is the R? Here R equal to taking 6h. Because I want in the height. Very easy. So I start volume of cone. This conical shape making. And what is the volume of cone? Yes, correct thinking. 1/3 pi r square h. Already written my formula in the first part. Yes, and here students, main point, you want to height increasing, so radius is no required. So radius 6h value you put down here. Means this value I put it here. Sometime asking here radius change, then you apply h 1/6 r in place of h. That different sum. So here volume B 1/3 by R value is what R value? 6h and into h. And here students, you making the one of the simplifications. And after that I start one of the little derivative. It's the very easy and simple sum. So what is the V? V I have 1/3 by 36 and h the cube, this cancel. So V equal to 12 by h cube. Students, one more time repeat. You want the height versus time. That's why I R value eliminate and apply derivative. with respect to time. So dv versus dt 12 pi, and your d by dt of h cube, very easy. dv by dt given 12 semi cube, and check your unit is same, semi, and you apply. It is 12, here 12 pi and 3x square dh by dt. Now 12 by 1, here 1 pi 3, and what is the h? 4 semi. So apply the 4 square dh by dt. So your answer is 1 pi, here 4 square 16 3s are 48 dh by dt. So my answer dh by dt is 1 upon 48 pi centimeter per second, and that's your height is increasing in the way of volume is entering every second 12 centimeter cube. Students, same sum in an exam asking how fast here radius change. Then you apply this height in direct your formula. Your height is volume 1/3 pi r square h. It's a different kind of sum. 1/3 pi r square. What is the h? 1 upon 6 r. So you can try pi by 6 3s are 18 r cube, and here apply derivative with respect to time. Here after that I find out dh by dt. You get it here dr by dt. If you asking in exam, yes students, it's also board already asking that questions. Yes students, here our question 14 is done, and this part is also done students. Further explanation for this exercise I explain you in the next part. Okay, bye bye, see you soon.